Let's start by drawing the first case and the second case. The first case is where the initial block of mass m is traveling with an initial velocity of u, and the second case is where the block has just collided with the sphere. Here is the collision, and the sphere will travel with a velocity of v2, while the block will travel with a velocity of v1. Let's write the equation that will give us the relation between u, v1, and v2. First is v separation equals v into v approach. Here the given coefficient of restitution E is half, so we can write v separation v2 minus v1 equals half into u, which will give us 2v2 minus 2v1 equals u. Second, we write the conservation of momentum equation in the direction of collision. I will show the direction of conservation momentum in green. We can write conservation momentum is mu equals mv2 plus mv1 in the direction of collision. We can cancel the common m on both sides and write u equals v1 plus v2. Taking both these equations, we can write 2v2 minus 2v1 equals v1 plus v2, which simplifies to give v1 equals v2 by 3. Replacing this in u equals v1 plus v2, we get u equals 4 by 3 v2. Now let's calculate the v2 required by the sphere to reach the top. Here comes the twist in the question, because this is not a string, it's a rod. In case of a string, we would have required a velocity at the top to counteract the weight using centrifugal force. But in case of a rod, we just need the mass to reach the top. And the top is at a height of 2 into the length of rod, which is 2L. So we can write half mv2 square is equal to 2 mgl. From this relation, we find out that v2 must be root 4gl, unlike in case of a string where it must be root 5gl. We replace v2 equals root 4gl to get u equals 4 by 3 into root 4gl. Now we can write the kinetic energy of the block initially is equal to the energy stored in the spring, which is nothing but half into k into x square, where x is the compression in the spring. This energy in the spring will convert into the kinetic energy of the block. Now replacing k equals mg by 3, which is given in the question, and replacing for u equals 4 by 3 root 4gl, we get this equation. Now we know L equals 3, so we can replace that and cancel the common terms, and we finally get the compression in the spring is 8 meters.